All right. Well, I hope everybody did an awesome job working with those practice problems. So, practice six is a very important one because knowing when to use Z intervals and T intervals is going to be really, really important because, again, these answers can be drastically different. So, the big thing that we want to remember between each of them is Z, again, is using the population standard deviation, T is using our sample standard deviation. And so we want to be able to identify that in these sentences to try to determine whether we're going to use T or Z for each of these. So when we see something like example A, suppose you took a sample of 50 men and found that they had a mean height of 68.5 inches with a standard deviation of 2.1 inches. So when they word it like that, the sample of 50 men and then follow it with the mean and the standard deviation, well, what that means is that, of course, the 68.5 is going to be our sample height, sample mean, sorry, but then that standard deviation that was found is also part of the sample. So it wasn't provided for us, it wasn't given to us. We calculated it as part of the sample process. So population standard deviation is going to be something that's given to us. And so the sample standard deviation is going to be something that we're finding, that we're calculating. So that's how we want to try to recognize the difference between the way these are worded or not. So since we're working with the sample standard deviation, this means we're going to be using t-scores or the t-interval for this one. So, and so you can go through and find the confidence intervals on your own. I just want to make sure we're getting the appropriate t's or z's as we go through. All right, so for B, for example, suppose we took a sample of 12 cans of soda, found that their mean weights were normally distributed with a mean of 12.05 and a standard deviation of 0.25. Construct a confidence interval, da 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 da. So again, the fact that that standard deviation was produced from that sample of 12 cans of soda tells us that this is going to be our sample mean of 12.05 and then a sample standard deviation of 0.25. So again, this one's going to be a t-score or t-interval again. All right. So for C, suppose we took a sample of 1,205 college students, found that the mean amount of hours they studied each week was 12.5 with a standard deviation of 3.8 hours. Again, construct a confidence interval. So again, that standard deviation is being found as part of the sample. So this is another t-score. All right, for D, suppose you took a sample of 20 doctors, found their mean IQ to be 125. Since we know the population standard deviation for IQs is 15, find the confidence interval. So notice with this one, the population standard deviation is actually being given. So far, this is the only one that we can use from 7.1. We're using our z-score approach. All right, and then finally, suppose you take a sample of 25 homeowners and found that insurance premiums are normally distributed with a mean of 660 per year with a standard deviation of 125 per year. So again, that standard deviation is being produced from that original sample of 25 people. So this is going to be our sample standard deviation. And so again, we're using our t-score. And so again, it's on purpose that I wrote it up this way, that we've got a lot more t-scores than z-scores, because that's what's going to happen in reality. It's going to be very, very rare for us to actually start off with the population standard deviation. So we want to be aware that the majority of the work that we're going to be doing for confidence intervals is going to live in 7.2. So kind of keep that in mind. All right, so now that we've got exactly which ones we know these should be, go back later, find the confidence intervals for them and stuff like that. So, all right, so good job, everybody. So if anybody has any questions or anything about this section, just let me know. Otherwise, I'll see you next time when we'll be talking about proportions. So good job, everybody.